Hello everyone. In this video, we will see how we can use Atom to create ELine services that transport all traffic across LDP network using an entire port at each endpoint using Ethernet circuit cross-connect as a physical encapsulation type. Service providers can limit the bandwidth of services built from this service definition to specific values from 10 Mbps to 100 Mbps. Atom offers predefined service definitions in the form of a profile that one can choose to create a particular service. A profile captures the commonly used parameters in a service. You can either edit them or you can create your own variation. Let us take a look at the service definition for port-based ELine service. Here we can see that the signaling is set to LDP and the pseudo wire type is set as Ethernet. In the connectivity settings, we can see the virtual circuit ID and MTU related configuration. For VCID, we can either feed in the ID during service creation, or we can choose to auto-pick from the resource manager in Atom IPAM. So we already have a profile created in the resource manager inside the Atom IPAM, and that has been chosen here. The MTU is set to 1522, and the MTU range bytes can be set as well. The PE-CE settings captures the configuration on the interface between PE and CE devices. We have chosen port as the Ethernet option. The VLAN normalization for this service is chosen as normalized to .1Q tag. But Atom also supports normalization not required in this particular scenario. The physical interface is set to Ethernet cross connect. The MTU can also be defined under the PE and the CE settings. Another important setting is the rate limiting parameter. We can choose the bandwidth in Mbps that will be configured as the firewall policy configuration. Let us now try to create a port-based ELine service. So we have the template loaded. Let's take a look at the fields. The initial set of parameters include the name, the customer name that is chosen from the drop-down, the service definition from the ELine profiles. In this particular case, it is ELine port based, and then the CFM profile from the drop-down that's coming from the CFM profile. In the connectivity settings, we can skip the VCID resource profile as we already mentioned auto-pick in the ELine profile. The RT profile can be skipped as it is not relevant in the case of LDP signaling. MTU, etc. will also be fetched from the ELine profile. The VLAN tag to stack should be given as we have chosen normalized .1Q as the VLAN normalization. Endpoint A and endpoint Z will capture the PE device settings with respect to the CE device. We have the PE device and the corresponding UNI interface. The unit number is given as an auto pick in the profile, but we can override that by specifying unit 0 as this is port based. If needed, the bandwidth can be modified to a value different from the ELine profile. Let us now try to create the service. As you can see, a new service is now created. Let us take a look at the task logs. In the provision commands on endpoint A, the initial configuration is a firewall and policy configuration that has the bandwidth and how it is applied to the interface. We can see the interface configurations where we can see unit 0 and no VLAN tag from the CE device. And then we can see the configurations for VLAN translation, and finally the L2 circuit details where we can see the remote endpoint configuration. We can also see the CFM configurations based on the chosen CFM profile. The second endpoint has similar configuration as well. On the device, we can see the same set of configurations. We can see the encapsulation configuration, the port configurations, we can see the firewall configuration, the firewall policy configuration, and how it is attached to the interface. We can see that there is no VLAN coming from the CE device, and all the traffic is now tagged with 256. The VLAN tag also gets popped when the traffic is in the reverse direction. The L2 circuit configuration can also be seen with the neighbor details of the remote endpoint. We can also see the CFM profile attached to the interface, and here is the configuration for the OAM protocols configuration for CFM on this particular device. The same set of configurations can be seen on the second device as well. Thanks for watching.